March 1944, Luftwaffe test facility, Lakefeld, Bavaria. A twin-jet fighter rolls down the runway at a speed no piston aircraft can match. Its nose dips, the wheels lift, and for the first time in combat aviation history, a jet-powered interceptor built for war enters operational testing under the flag of the Third Reich. The Messerschmitt. Me-262 Schwalbe, Swallow, has arrived. It will become the world's first operational jet fighter, a machine so fast that Allied pilots will have only seconds to react, a design so advanced that it will haunt post-war aviation for decades. But it will not save Germany, and its failure will hinge not on engineering, but on decisions made far from the drafting table. This is the story of how a young engineer's rejected design became the Luftwaffe's most dangerous weapon, and how a cascade of strategic blunders ensured it would arrive too late, in too few numbers, to alter the outcome of World War II. The story begins not in 1944, but 6 years earlier in the Berlin office of the Reich Air Ministry. It is 1938. The Luftwaffe is ascendant, its ranks swelling, its doctrine honed by the Spanish Civil War. Willy Messerschmitt, already celebrated for the Bf 109, Germany's frontline fighter, is sketching something new, something radical. He envisions a fighter powered not by a propeller, but by turbojet engines, a technology so experimental that only a handful of engineers worldwide believe it can work. At the same time, across Germany, a young physicist named Hans von Ohain is running tests on a prototype turbojet at the Heinkel Works in Rostock. Von Ohain is 28 years old, a doctoral graduate from the University of Göttingen, and he is obsessed with a single problem: how to generate thrust without a propeller. His solution is elegant. Air enters the front of the engine, is compressed by a centrifugal impeller, mixed with fuel, ignited, and expelled at high velocity through a nozzle. No reciprocating pistons, no crankshaft, no propeller, just continuous rotation and pure thrust. In August 1939, von Ohain's engine propels the Heinkel Hebei 178 into the air for 11 minutes. It is the world's first jet-powered flight. But the Reich Air Ministry is unimpressed. Jets are experimental, unreliable, hungry for rare metals. Piston engines dominate the sky, and Germany's leadership sees no reason to divert resources toward unproven designs. Messerschmitt's jet proposal is shelved, not canceled, just delayed. It will remain on paper for 3 more years while Germany conquers Poland, France, and the Low Countries with propeller-driven aircraft. Then the war turns. In the summer of 1940, the Luftwaffe loses the Battle of Britain. Hermann Göring, commander-in-chief of the Luftwaffe, had promised Hitler that the RAF would be destroyed in 4 weeks. It takes 4 months, and it fails. German fighters, despite their technical excellence, cannot maintain the operational tempo required to suppress British airfields, radar stations, and industrial centers. Attrition favors the defender. By September 1940, the Luftwaffe has lost over 1,700 aircraft. The invasion of Britain is canceled. Then, in June 1941, Operation Barbarossa opens the Eastern Front, stretching German air power across 2,000 miles of steppe, forest, and tundra. Luftwaffe units are dispersed from Leningrad to the Crimea. Sortie rates climb, maintenance cycles shorten, losses mount. By the winter of 1941, the Luftwaffe is flying worn-out aircraft with exhausted pilots against an enemy that seems to have limitless reserves. Then, in 1942, the strategic bombing campaign begins. American B-17 flying fortresses and British Lancasters strike factories, rail yards, and oil refineries with increasing frequency. German interceptors, chiefly the Bf 109 and the newer FW 190, are effective, but they are not fast enough to catch bombers at high altitude, and they burn fuel rapidly in the climb. The Bf-109G, the most common German fighter in 1942, has a top speed of 385 miles per hour at 22,000 feet. The B-17, cruising at 25,000 feet, flies at 287 miles per hour. The speed differential is only 98 miles per hour. That gives a German pilot a narrow window to intercept, attack, and break away before American escort fighters, P-47 Thunderbolts and later P-51 Mustangs, close in. The FW-190 is faster, with a top speed of 408 miles per hour. But it struggles at altitude. Its radial engine loses power above 20,000 feet, precisely where the bombers fly. German pilots need more speed, more climb rate, more firepower. They need a jet. The Reich Air Ministry, now facing attrition on 3 fronts, revisits Messerschmitt's jet proposal. In January 1942, the ministry grants approval for full development of a twin-engine jet fighter. Messerschmitt assigns the project designation Me-262. The lead engineer is a 31-year-old designer named Voldemar Voigt. He is methodical, precise, and uninterested in compromise. Voigt's design calls for a swept-wing airframe, twin Junkers Jumo 004 axial flow turbojets, and a tricycle landing gear, all radical departures from contemporary German fighters. The wing sweep is 18 degrees, a feature intended to delay the onset of compressibility at high speed. No operational fighter in the world uses swept wings. The tricycle gear, nose wheel forward, mains aft, is equally unconventional. Nearly every fighter of the era uses a taildragger configuration. Voigt insists the tricycle layout is necessary. The jet engines produce thrust along a horizontal axis, not the vertical thrust line of a propeller. A taildragger would force the Me-262 to take off with its nose high, creating dangerous angles of attack. The tricycle gear solves this. It also improves pilot visibility on the ground, a critical advantage during taxiing and landing in combat conditions. But it is heavier, more complex, and it requires stronger landing gear struts, which demand better steel alloys. Steel that Germany, by 1942, is already struggling to secure. The Reich Air Ministry questions the design. Messerschmitt defends it, and Voigt refuses to change it. He is right. But being right will not be enough. The first prototype, Me-262V1, is completed in April 1942 at Messerschmitt's Augsburg facility. It has no engines. The Jumo 004 turbojets are still in development, plagued by metallurgical failures and turbine blade fractures. So the V1 is fitted with a single Jumo 210 piston engine in the nose, a humiliating compromise for a jet fighter. It flies under piston power on April 18, 1942, at Augsburg. Test pilot Fritz Wendel reports that the airframe handles well, with responsive controls and stable flight characteristics. But it proves nothing. A jet fighter without jet engines is just an expensive glider with a piston engine grafted onto the nose. Not until July 18, 1942, does the Me-262 V3 prototype fly with 2 operational Jumo 004 engines. Wendel takes it up from Leipheim Airfield at dawn. The takeoff is smooth, the acceleration breathtaking. At full throttle, the Me-262 reaches 540 miles per hour in level flight, nearly 100 miles per hour, faster than any Allied fighter then operational. Wendel reports excellent handling, responsive ailerons, and a stable platform for gunnery. He also reports one critical flaw. The Jumo 004 engines flame out unpredictably under rapid throttle changes. This is not a design flaw in the airframe. It is a materials problem. The Jumo 004's turbine blades are made from a nickel-chromium alloy called tinadur. But by 1942, Germany's supply of chromium and nickel is dwindling, strangled by the Allied blockade and the loss of access to Soviet resources after the launch of Barbarossa. Junkers engineers are forced to substitute inferior alloys, steel with reduced chromium content, blades coated with aluminum rather than heat-resistant ceramics. The result? Turbine blades that warp under heat, crack after 25 hours of operation, and fail catastrophically if the throttle is advanced too quickly. A Jumo 004 engine, under ideal conditions, is rated for 35 hours of operation before requiring a full overhaul. In practice, most fail after 10 to 15 hours. Some last only 5. The Me-262's airframe is flawless, its engines are not, and time is running out. In November 1942, Adolf Galland, general of the fighter arm and Germany's most decorated ace with over 90 confirmed kills, flies the Me-262 for the first time at live fame. He takes off, he accelerates, he climbs to 20,000 feet in under 6 minutes. He dives. He levels out at 520 miles per hour and holds it there, effortlessly. He lands. He walks directly to the telephone in the operations building. He calls Berlin. "This aircraft," he says, "will guarantee us an operational superiority that we have lost." Galland urges immediate mass production. He envisions squadrons of Me-262s rising to meet Allied bomber streams, slashing through formations at speeds no escort fighter can match. He requests 2,000 aircraft by the end of 1943. The Air Ministry agrees to begin production, but the order is limited. 60 pre-production aircraft with full-scale production to follow in mid-1943. Galland is furious. He knows 60 aircraft will prove nothing. He also knows that the Allies are building bombers faster than Germany can replace its losses. In 1942 alone, the United States produces 47,836 aircraft. Germany produces 15,556. The disparity is growing. And the Me-262, the one aircraft that might restore balance, is being delivered in handfuls. Then, in May 1943, Adolf Hitler sees the Me-262 for the first time. He watches it take off from Insterburg in East Prussia, its twin jets howling. The aircraft climbs at a steep angle, faster than any fighter Hitler has ever seen. He is impressed. After the demonstration, Hitler walks over to Messerschmitt and his team. He asks a single question: "Can this aircraft carry bombs?" Messerschmitt hesitates. The Me-262 is a fighter. Its airframe can carry ordnance, yes, but not without sacrificing speed, range, and maneuverability. Adding bomb racks will require structural reinforcements. It will shift the aircraft's center of gravity. It will delay production by months. But Messerschmitt knows he cannot refuse the Führer. He says yes. It can carry bombs. Hitler issues an immediate order. The Me-262 will be developed as a fast bomber, a blitz bomber, capable of striking Allied invasion forces when they land in France. This is May 1943. The Allied invasion of France is still 13 months away, but Hitler is convinced it will come soon, and he believes the Me-262 can help repel it by hitting landing beaches, supply depots, and troop concentrations at speeds too fast for Allied fighters to intercept. Galland is horrified. He argues that the Me-262's value lies in its speed and firepower, not in its ability to carry 500-pound bombs at reduced performance. He argues that Germany needs interceptors, not light bombers. He argues that converting the Me-262 into a bomber will delay production by months, perhaps a full year. Hitler overrules him. The Me-262 program is redirected. Messerschmitt engineers begin designing bomb racks capable of carrying two 250-kilogram bombs, one under each side of the forward fuselage. Hardpoints are added, structural reinforcements are installed to handle the weight and aerodynamic stress. Wind tunnel tests reveal that the bomb racks create significant drag, reducing the Me-262's top speed by nearly 40 miles per hour. Delivery schedules slip. Factories retool. Pilots are retrained for ground attack missions rather than high-altitude interception. By the time the first production, Me-262A1, A fighters reach operational units in July 1944, the Normandy invasion is already 6 weeks old. The Blitzbomber order has cost Germany 9 months. 9 months in which Allied air superiority has hardened into total dominance. 9 months in which Me-262s could have been intercepting bomber streams over Berlin, Munich, and Stuttgart. When the Me-262 finally enters combat in the summer of 1944, it is everything Galland promised. It is fast, it is deadly, and it is terrifying. On July 25, 1944, an Me-262 flown by Lieutenant Alfred Schreiber of Erprobungskommando 262, a test and evaluation unit, intercepts a formation of British Mosquito reconnaissance aircraft over Bavaria. The Mosquitoes, among the fastest Allied aircraft in service with a top speed of 415 miles per hour, can typically outrun German fighters. Not this time. Schreiber closes from behind at over 500 miles per hour, fires a burst from his 430mm Mk-108 cannons, and destroys one Mosquito in seconds. The others scatter. Schreiber is untouchable. He circles once, checks his fuel, and returns to base. By August, Me-262s are flying regular sorties against American bomber formations. Pilots report that the jet can climb to 30,000 feet in under 7 minutes, half the time required by a Bf-109. It can overtake a B-17 from behind, fire, and break away before the bomber's gunners can track it. And its 4 Mk-108 cannons deliver devastating firepower. A single hit from a 30mm shell can cripple a bomber. The Mk-108 fires a high-explosive incendiary round weighing 330 grams. The muzzle velocity is low, only 540 meters per second, which makes long-range gunnery difficult. But at close range, the shells are catastrophic. 1 hit can sever a wing spar, 2 can blow off a tail section, 3 can ignite fuel tanks. American pilots call the Me-262 the blow job, a crude reference to the jet engine's howling sound as they accelerate past bomber formations. They have no tactical counter. The P-51 Mustang, the Allies' best escort fighter, has a top speed of 440 miles per hour. The Me-262 is 100 miles per hour faster. Dogfighting is impossible. The only way to kill an Me-262 is to catch it during takeoff or landing when it is slow and vulnerable. Allied commanders issue a directive in September 1944. Patrol known Me-262 airfields. Attack jets on the ground or in the landing circuit. Shoot them down when their wheels are down and their speed is below 200 miles per hour. It works. But it also reveals how few Me-262s are operational. On most days, Allied pilots see no more than 2 or 3 Me-262s in the air at once, sometimes none. Because even in late 1944, production remains catastrophically low. Messerschmitt's factories are being bombed weekly. The Regensburg plant, which produces the Me-262's fuselage, is hit 5 times between August and October 1944 by formations of B-17s escorted by P-51s. Each raid destroys machine tools, kills skilled workers, and forces production underground. The Augsburg final assembly plant is struck repeatedly. In one raid on February 25, 1944, over 400 American bombers dropped more than 800 tons of ordnance on Messerschmitt facilities. The main assembly hall is flattened. 17 completed Me-262 airframes are destroyed. 40 more are damaged beyond repair. Bombed factories are rebuilt in forests, in tunnels, in dispersed workshops hidden across Bavaria and Thuringia. Workers assemble Me-262s in clearings under camouflage nets, using hand tools and improvised jigs. Quality control disintegrates. Engines arrive with mismatched turbine blades. Airframes are delivered with cracked wing spars, misaligned control surfaces, and improperly sealed fuel tanks. Jets roll off the line and fail within hours. In September 1944, Germany produces 91 Me-262s. In October, 150. In November, 200, but fewer than half are combat-ready at any given time. The rest sit grounded, waiting for parts, for engines, for fuel. By comparison, the United States produces over 9,000 aircraft in November 1944 alone. Ford's Willow Run plant in Michigan produces one B-24 Liberator bomber every 63 minutes. North American Aviation in California produces 15 P-51 Mustangs per day. Germany's entire Me-262 program from 1942 to 1945 will produce 1,430 aircraft. Only 200 will fly combat missions. The men who fly them are among the Luftwaffe's best. In October 1944, Adolf Galland forms Jagdverband 44, an elite jet unit staffed entirely by veteran aces. Galland himself leads it. His pilots include Johannes Steinhoff, Gerhard Barkhorn, Heinz Baer, and Günther Lützow, men with hundreds of confirmed kills between them. Steinhoff has 176 victories. Barkhorn has 301, the second highest tally of any fighter pilot in history. Baer has 220. They are not rookies learning to fly a new aircraft. They are the Luftwaffe's best, transitioning from piston fighters to jets in the final months of the war, and they are old. Steinhoff is 33, Galland is 32. By the standards of 1944, when most Luftwaffe pilots are 19 or 20, they are ancient. They fly from Münchberg in northern Bavaria, then Brandenburg-Brest north of Berlin, then finally Munich-Riem as the front collapses. They score kills. Steinhoff downed 6 American bombers in 2 weeks. Baer claims 16 kills in the Me-262 before war's end, making him the jet's top-scoring ace. But the numbers do not matter. Because for every Me-262 that takes off, 50 Allied aircraft are already in the air. The jet can kill bombers. It cannot stop the bomber streams, and it cannot protect Germany's cities. On April 7, 1945, 1,300 American heavy bombers strike targets across northern Germany, escorted by over 850 P-51 Mustangs. Jagdverband 44 scrambles 8 Me-262s from Munich-Riem. They climb through broken clouds at 15,000 feet and intercept a formation of B-17s over Ingolstadt. Galland leads the attack. He selects a B-17 on the left flank of the formation, closes to 200 meters, and fires a 3-second burst. The bomber's number 3 engine explodes. The wing folds. The aircraft enters a flat spin and goes down. Galland breaks right, accelerates, and lines up on a second bomber. He fires again. This time, the rounds miss. He's out of ammunition. He dives away, heading for Munich. Behind him, P-51s are circling, waiting. They do not chase him. They wait. One P-51 pilot, Captain James Finnegan of the 357 Fighter Group, spots in Me-262 descending toward Munich-Riem at low speed. He closes in. The jet pilot sees him and tries to accelerate, but the engines are slow to spool up. Finnegan fires. The first burst misses. The second hits the Me-262's left engine nacelle. Fire erupts. The jet wobbles, noses over, and crashes into a field 3 kilometers short of the runway. The pilot does not bail out. It is Galland's wingman, Oberleutnant Eduard Schallmoser. He is 24 years old. He has 71 kills. He dies 2 weeks before the war ends. By April 1945, the Third Reich is dying. Soviet forces are fighting in Berlin's suburbs, block by block. American troops have crossed the Rhine and are advancing east at 40 kilometers per day. Jagdverband 44 is flying from a cratered runway at Munich-Riem, using the Autobahn as a taxiway because the main runway is too damaged for safe operations. Fuel is rationed to 15 minutes per sortie. Ammunition is scarce. Each Me-262 is loaded with only 100 rounds per gun instead of the standard 150. Ground crews work in shifts around the clock, cannibalizing damaged aircraft for spare parts. There are no replacement engines, no replacement pilots, no reserves. On April 26, 1945, Galland flies his last mission in a Me-262. He takes off at 14:30 hours with 7 other jets. They intercept a formation of American B-26 Marauders over Munich. Galland closes on the lead bomber and fires. The B-26's left wing shears off. He lines up on a second bomber and fires again. This one explodes. Then, return fire from a Marauder's dorsal turret hits Galland's Me-262 in the right knee. The canopy shatters. Hydraulic fluid sprays across the cockpit. Galland feels his leg go numb. He disengages, dives to treetop level, and crash lands in a field near Salzburg. His knee is shattered. He will never fly again. The war ends 12 days later. The Me-262 outlives the Reich. When Allied forces overrun German airfields in May 1945, they find dozens of Me-262s intact, abandoned, fueled, armed, and ready to fly. American and British engineers dismantle them. They study the swept wings, the tricycle gear, the engine nacelles, the wing root cannons. They photograph every rivet, every weld, every structural joint. They measure wing thickness, dihedral angles, control surface deflection limits. They test fly captured examples. They ship airframes back to Wright Field in Ohio, to Farnborough in England, to testing facilities in France and the Soviet Union. And they copy everything. The Boeing B-47 Stratojet, America's first swept-wing jet bomber, enters service in 1951. Its wings are swept at 35 degrees, twice the sweep of the Me-262. Its engines are potted under the wing, just like the Me-262, rather than buried in the fuselage or wing roots. The North American F-86 Sabre, which will dominate the skies over Korea from 1950 to 1953, uses a swept wing derived directly from German research captured at Messerschmitt facilities. Even the Soviet MiG-15, the Sabre's adversary, owes its planform to captured German wind tunnel data and interviews with German engineers who were transported to the Soviet Union after the war. The Me-262 does not win the war, but it defines the jet age. Every jet fighter and bomber designed in the decade after 1945 borrows something from the Me-262. Its swept wings, its potted engines, its tricycle gear. The engineers who designed it do not profit from this legacy. Woldemar Voigt, the engineer who designed the Me-262's airframe, survives the war. He works briefly for the French government, providing technical expertise on German jet development. Then, he returns to Germany and takes a position with a small aerospace firm in Bavaria. He never speaks publicly about the Me-262. He never writes a memoir. He never gives interviews. He dies in 1973, largely forgotten outside aviation circles. Willy Messerschmitt is tried at Nuremberg for using slave labor in his factories during the war. Evidence presented at trial shows that over 30,000 forced laborers, prisoners from concentration camps, Soviet POWs, and conscripted foreign workers were employed at Messerschmitt plants between 1943 and 1945. Thousands died from malnutrition, disease, and abuse. Messerschmitt is convicted. He serves 2 years in prison. After his release in 1948, he works as a consultant for the Spanish and Egyptian air forces, helping both nations develop domestic aircraft industries. He dies in Munich in 1978 at the age of 80. Adolf Galland emigrates to Argentina in 1948, where he advises Juan Perón on Air Force modernization and tactical doctrine. He returns to Germany in the 1950s, writes his memoirs, The First and the Last, and becomes a celebrated voice in aviation history. He attends air shows, gives lectures, and corresponds with former Allied pilots, including Douglas Bader and Bob Johnson. He dies in 1996 at the age of 83, still insisting that the Me-262 could have changed the war if deployed earlier and in greater numbers. He is probably wrong, because even if the Me-262 had entered service in early 1943, even if Hitler had not ordered it converted into a bomber, even if production had reached 1,000 aircraft by the time of the Normandy landings, it would not have been enough. The Allies had numbers. They had fuel. They had factories in Detroit, in Birmingham, in Wichita, in Los Angeles. factories far beyond the reach of German bombers, factories that could produce aircraft faster than Germany could destroy them. Germany had innovation. It had brilliant engineers, skilled test pilots, and a technological lead in jet propulsion. But innovation cannot replace industry. And industry cannot run without oil, chromium, tungsten, or nickel, all of which Germany lost access to by 1944. The Reich's synthetic fuel plants, which produced gasoline and diesel from coal, were bombed repeatedly in the summer and fall of 1944. By December, fuel production had dropped by 90%. Me-262S sat on runways, fully armed and ready, but unable to fly because there was no fuel to put in their tanks. The Junkers engine plants, which produced the Jumo 004 turbojets, were bombed so frequently that production fell to a trickle. By March 1945, fewer than 50 operational engines were being delivered per month. The Me-262 was the best fighter of World War II, but it arrived in a war already lost. It could not reverse the tide. It could only delay the inevitable. There is a moment in the history of the Me-262 that encapsulates everything. It is April 19, 1945. Soviet artillery is shelling Berlin from the eastern suburbs. American forces are 50 kilometers west of Munich. At Munich-Rhein, a single Me-262 sits on the taxiway, its engines running. The pilot is Lieutenant Fritz Müller, a 22-year-old ace with 19 kills. He has just received orders to scramble and intercept a formation of American P-47 Thunderbolts reported over Augsburg. He releases the brakes. The jet rolls forward. Then the left engine flames out. Müller cuts the throttle, tries to restart it. The engine coughs, spools up, flames out again. He shuts down both engines. He climbs out of the cockpit. He walks to the operations building and reports the failure to the duty officer. The duty officer tells him there are no replacement engines. There are no mechanics available. There is no fuel to test run a repaired engine, even if one could be found. Müller is told to wait. He waits. The sortie is canceled. The P-47s bomb Augsburg unopposed. 3 days later, American troops enter Munich. The war for Müller and for the Me-262 is over. There is a photograph taken in May 1945 of a Me-262 sitting abandoned on a grass airstrip outside Munich. Its canopy is open. Its fuel tanks are empty. Weeds are growing through the wheel wells. The left engine cowling is missing, exposing the turbine blades to the elements. No one knows who flew it last. No one knows how many sorties it completed. It is simply there, a relic, a monument to what might have been. An American soldier stands beside it, one hand resting on the wing. He's looking at the camera, smiling. Behind him, the jet sits silent, its nose pointed east, toward a war that no longer exists. The jet age would come, but it would not belong to the engineers who designed it first. It would belong to those who could build it in numbers, fuel it, maintain it, and deploy it without pause. The Me-262 was a triumph of engineering. Its failure was a lesson in logistics, in strategy, in the brutal arithmetic of industrial war. And in war, logistics always wins. Innovation can give you an edge. But mass production decides the outcome. Germany learned this too late. The Me-262 is remembered today not as the weapon that changed the war, but as the weapon that almost did. Almost. That word carries weight. It is the distance between genius and victory, between design and deployment, between what was possible and what was achieved. The Me-262 bridged the gap between the propeller age and the jet age. It proved that jet fighters were not just feasible, but superior. It terrified Allied pilots, influenced post-war aircraft design, and demonstrated that speed in air combat is the ultimate advantage. But it could not overcome the industrial disparity between the Axis and the Allies. It could not reverse the loss of strategic resources, the destruction of German factories, or the collapse of fuel supplies. It could not change the fact that Germany was fighting a two-front war against enemies with limitless reserves. The Me-262 was the future, but the future arrived too late to save the past.